trigonometry can be confusing, but there's some key things you need. Okay, in this integration video, I will also list some very key trigonometric things that you need to know that will help you throughout P3, P4. Just some key identities and the key ones you need to know. So let me list them down so that you know them. First of all, sine squared plus cos squared. Of course, there are x's there. You can't do sine of nothing. But sine squared plus cos squared is 1. And then divide everything by sine squared. So 1 plus cot squared is cosec squared. And then this original one divided by cos squared, we get tan squared plus 1 is sec squared. So you remember this. Hopefully you know how it comes. It just comes from this fundamental one. When we divide by sine squared first, we get this. And when we divide by cos squared, we get this. So these three are fundamental. And then the addition formula, the double angle one. Sine of 2a is just 2 sine a cos a, and cosine of 2a is cos squared a minus sine squared a. Remember, now this one can be simplified to cos squared is the same as 1 minus sine squared from here. 1 minus sine squared a minus another sine squared a, so minus sine squared a. So this is the same as 1 minus 2 sine squared a. And then you can also make it in terms of cos only. So that way it becomes cos squared minus 1 minus cos squared, which gives, from here, replacing sine squared with 1 minus cos squared, we get 2 cos squared a minus 1. Because that negative sign will make both of this, will now make it like that, and then that original cos squared plus cos squared, 2 cos squared minus this one. So in conclusion, you need to know all this. So let me just write this as 1 minus 2 sine squared a. So this is all the trig identities you need to know, and all the manipulation you will be needed when you're doing hard integration questions or hard trigonometric questions. It'll all be just this. This one is very easy, you know it. These two comes from this, and then this one is also key, and then this one is actually more key. This one will show up many times. I'll show you how. So this 6 is the fundamentals, basically everything you might need for trigonometry in P3 and P4. So keep this in mind. So from here we go to integrating complex trigonometric functions using the identities I showed. Sometimes the integrand can be so complex in terms of trigonometric functions that it cannot be integrated directly. So you have to manipulate it, you have to change it so that now we get an expression, an integrand that can be integrated using the key definitions I showed first. So let's see. Integral of tan squared x dx. Now, this is not as easy as it seems. Firstly, a key misconception, something even I suffered with. You might think, oh, this is the same as tan x all squared. Let me integrate the outside function and then divide by the derivative of the inside function. So that would give tan x all cubed over 3, and then the derivative of the inside function is sec squared x plus c. This is absolute bullshit. Even I was confused like this in the beginning, but it doesn't work simply because the derivative of the inside function itself has an x term. So you can't use the general reverse chain I showed before. The derivative of the inside itself has an x, so we can't use it. Remember, when we were doing it just a minute ago, ax plus b was differentiating to a, so dividing by just a constant. If at any point it's not linear and it's a quadratic, say ax squared plus b, the derivative of the inside was coming out to be 2ax. Itself was having an x term in it. So you can't just use this general term, because in this case, it's not any power on x, but the derivative of tan x itself has x. So we can't use this. This just maybe such a thought spiked in anyone's head, but we can't use that because the derivative of the inside function itself has x. You can only use it when the derivative of the inside function is simply a constant. So in this case, tan squared of x, remember from that identity we said sec squared is 1 plus tan squared. 1 plus tan squared x. So tan squared is the same as sec squared minus 1. So this one becomes sec squared x minus 1 dx. And then this one we know because the derivative of sec squared is just tan x. Derivative integral, sorry, my bad. The integral of sec squared is just tan x. The integral of 1 is just x plus c, minus x plus c. Yeah. So this is the answer. So this is how you might have to manipulate very complex trig functions. Now, another key thing, it will show up in P3, P4, everywhere when you are told to integrate sine squared x and cos squared x. This can be found anywhere, and then if you don't know how to do this, it's kind of a bad situation. So let me whatever this immediately. This thing will show up also in P4. So for this, we can't integrate it directly. We have to use the identity cos 2x is the same as 1 minus 2 sine squared x or 2 cos squared x minus 1. Remember, I proved this just one page ago. So from here, when you do the manipulation, you will see that cos squared x is the same as half plus half cos 2x, and sine squared x is always half minus half cos 2x. So you see this, when the most needed trig functions I listed, this is also part of it, just that it can be derived from here, so I didn't list it. But these two are also very key because of integration. When we are told to integrate cos squared x, we have to know that it's the same as half plus half cos 2x. When we're told to integrate sine squared x, we should know that it's the same as half minus half cos 2x. So from there, we are now able to solve many hard questions, P3, P4. So integral of sine squared x will become integral of half minus half cos 2x dx. And this one will become half plus half cos 2x dx. So not that you should cram, but then with time you just remember it. Cos squared x is just half minus half plus half cos 2x, and sine squared x is half minus half cos 2x. Remember, the only difference between these two is just this minus and this plus. Here it's half minus half cos 2x, and here it's half plus half cos 2x. So that's the only difference. So, and then you can now expand this so that if it's sine squared of, let's say, 2x, then this would become 4x. If it's integral of cos squared 6x, this would be the same as half plus half cosine 12x dx. Because you see, don't you, when it's cos squared x, it's cosine of 2x. Whatever here, it becomes 2 times that. So if it's 6x here, it becomes 12x here. So from this basic stuff, you can come up with a lot of stuff. And obviously, you can integrate now this. If you're told to integrate just this, you know, the integral of half is just half x. And the integral of negative half cosine 2x. So cosine will differentiate to positive sine. The 2x remains because it's an inside function, and then because it's linear and the derivative of the inside function is just 2, we can divide by it, so we get minus 1 over 4 sine 2x plus c. I think this is the integral. Yes, exactly. The integral of half is half x, so you know that, and then cosine 2x becomes sine 2x, and yes, this is the answer for this, and you can do a similar thing for this and you'll get the answer. So that is almost it. For using all those those 6 trig identities I listed is the hard stuff, but once you've got it, it won't be that hard, trust me. So let's see. Oh, okay. So integral of sine 3x cosine 3x dx. Now, this could seem very confusing. This could seem very hard because it's very hard to integrate this just as it is. So here we use the identity sine of 2a gives 2 sine a cosine a. So see, you see a pattern here. This is the same as sine 3x cos 3x, and here 2 sine a cos a. So it must be sine of 6x, but then since there is a 2 here, but here it's a 1, so the fact that it's 1 sine 3x cosine 3x. So I'm just trying to show you the pattern here. Sine a cos a, we see it's similar here. So whatever a is here, 3x, here it should be 2a. So that's why I put 6x here. And then here it's 1. It's this term, the coefficient of the right hand side is 2 times the coefficient of the left hand side, which is 1. So if in this case it's 1 here, then here it should be half. So in conclusion, this whole thing is just integral of half sine of 6x dx. And then this is very easy. Sine becomes negative cos, 6x remains because it's an inside function. And then you divide by 6, so all over 12 plus c. Exactly. Yeah. So that and more questions you can look at in the textbook, where we are just simplifying complex trig shit into easier trig shit. You will get it. Now the reverse chain rule. Reverse chain rule is, you see, P3 integration is relatively easy. P4 is where P4 is where some things will happen, but don't worry, you will also get that. But the reverse chain rule, as I said, the first thing was f of ax plus b. We use reverse chain rule here. Then a second case, and P3 integrals will always be made in the exam questions. It will always be such that it's so simple to spot. When a function can be written in the form of, okay, when an integrand, when something that you're integrating, you see some pattern like this. The numerator is a derivative of the denominator. The numerator happens to be the derivative of the denominator. When you differentiate the denominator, if you get the numerator or some constant adjustments to it, then know that this is a case of reverse chain rule, and it's easy to do. Just firstly acknowledge that, then we can do it. So let's address this. When a function, when an integrand, something you're integrating, can be written in such a form. When you notice this, that the numerator is a derivative of the denominator or a constant adjusted. Remember, constants will not affect, so if there's a constant adjustment, it's the same thing. So let's see an example. When we're integrating 2x over x squared plus 1 dx. So in this case, have a look. What's the derivative of the denominator? 2x, right? And that also happens to be the numerator. So the answer is usually just ln of the denominator, x squared plus 1 plus c. So yeah, now you see why this is correct. Try differentiating this. We will get 1 over this times the derivative of the inside function. Remember, this would be a chain rule, so times 2x, and yeah, so we get the same thing back. Okay, remember, in integration, you can't divide, you can't just say divide by the derivative of the inside function if the derivative of the inside function itself has x. You can't do that in integration, but in differentiation, that's fine. In differentiation, we can multiply by the derivative of the inside function when we're using chain rule. So when we differentiate this, we get 1 over x squared plus 1 times the derivative of the inside function 2x. You might say, oh, you just said that if the derivative of the inside function happens to have x, you can't use it or something. That's for integration. When you're integrating, you can't just use reverse chain by dividing the derivative of the inside function if itself has x. But when differentiating, remember, when differentiating, we multiply by the derivative of the inside function. So when differentiating, when we multiply by the derivative of the inside function itself can have x. That's fine. It's only in integration it causes problems. So this is true. You can verify it using using the normal chain rule. Rather, when we differentiate this using chain rule, we get this. So this must be true. Part B. Integral of cosine x all over 3 plus 2 sine x dx. Now here again you see that the derivative of 2 sine x is 2 cos x. So it's just a constant adjustment that's missing. Everything else is okay. So let's see. So the integral of this would be ln of 3 plus 2 sine x plus c over 2, half of this. Now you might say, where did you just get this? Because I've done practice myself, but then you guys, it's easy to see that, because try differentiating this now. You get this answer. So the basic part is recognizing when the numerator is the derivative of the denominator, and then so the answer is usually just ln of denominator and some constant adjustment. The constant adjustment, you get it by trying to differentiate this. When we differentiate just this, we will get okay. Now that we know the answer, I can do this. When we differentiate this, the equal sign will now, we don't need that. When we differentiate this, we would get this, but we only want this. So we divide both sides by 2. So now the integral comes out to be this. So I think you get it. Yes. So yeah, the textbook says to integrate functions of the form k f prime of x over f of x. First of all, it's usually just ln of f of x being the denominator. So the textbook says try this and then differentiate to check and then adjust for the constant. This constant, adjust for it. Yeah? Okay. So that adjustment is easy once you understand this intuitively. So yes, exactly. If there is a constant here or any constant mismatch, if the derivative of this is not exactly this, but all that's missing is a constant, you have to adjust it later. But the main part of the answer is just ln of the denominator, ln of x plus c. So that's it for this. And then the last thing in P3 integration is using reverse chain rule to integrate functions of the form k f prime x f of x all raised to n. So to decode this, if you have a function raised to n multiplying by another function which happens to be the derivative of the inside function here, we use reverse chain rule. Forget this k. It will be there, it might be there, might not be there, but that one you just need to do a small adjustment for the k. So in conclusion, if you have a function raised to n and it's also multiplied by the derivative of the function, then this one is not raised to any power, it's just the derivative. Yeah. So if you have a function raised to n and it happens to multiply with its own derivative and you're trying to integrate this, it's a case of reverse chain rule, and the general answer is f of x all raised to n plus 1. This is the normal answer, and then you have to adjust for constants. Because think about it, this is reverse chain rule, because if we differentiate this using chain rule, we would subtract 1 power, we would multiply by n, and we would multiply by the derivative of the inside, which is f prime times f prime. So you see how the integral of this is this, because when we try differentiating this, we get something like this, which happens to match this. And the only thing that's needed now is to adjust the constant. So yes, so in conclusion, let's see examples. We have an example here: 3 cosine x sine squared x dx. So now here you see that this sine squared x, we can put it as sine of x all squared 3 cosine x integral of dx. Now you see that general thing here, don't you? We have an inside function, we have a function raised to a power 2, and then the derivative of the inside function happens to show up here, cosine. And then 3 is just there, forget about 3. So this answer would be sine x cubed. Yes. Oh, that's it. Actually, that's it. Now, that constant adjustment, you see it by differentiating this. When we differentiate to this, we get 3 sine squared x cosine x, which is exactly this. So if it matches, you don't need any constant adjustment. It's already done. The answer is just 1. Hence, this is the answer. So, that general thing I showed you, when you have a function raised to a power, and then the derivative also happens to be there, you just add 1 to the power of the function. It just becomes f of x raised to n plus 1, and then you adjust for a constant. So this is the answer. Let's see another example. Integral of x squared plus 5 all cubed dx. So here, look at it. The derivative of this inside function is 2x. So x here. So that 2 is a constant. Forget about it. We adjust it later. So this matches that general form we wanted. So the answer should just be add 1 to the power 4 plus c. And then now we try to adjust for constants. What do you think the constant is? Let's try differentiating this. So we would get 4 into x squared plus 5 all cubed times the derivative of the inside would be 2x. So this thing in general is giving us 8x squared plus 5 cubed. So when we differentiate this, we're getting this, but we only want it to be 1x. So the answer should be this divided by 1 over 8. I mean, this times 1 over 8, or the whole thing divided by 8. And now when you differentiate this, you'll get exactly this. So that's the answer. Exactly. So, yeah, in general, when you have a function in the form like that, just add 1 to the power of this and adjust for a constant by differentiating and checking. So that is it for the whole of P3 integration. Yes, that's it. So in summary, basic definitions, know those. Just know the first 5, I think. The other ones are in the formula booklet. And then when we have f of a ray x plus b, okay, let me list this later because it's also part of reverse chain. Trig functions, I listed you the main fundamental trig functions you need to know to manipulate shit so that you can simplify expressions you can't integrate into expressions you can integrate. So I listed these fundamentals. Remember, sine squared is half minus half cos 2x. Cos squared x is half plus half cos 2x. This is very key. Please just put it in your memory. I don't know. And then for reverse chain rule, we saw applications of f raised to ax plus b, where this has to be linear because we will divide by its derivative, which we want to be just a, nothing involving x anymore. So that when it's of the form f prime x over f of x, the general answer is just ln f of x, ln of the denominator, modulus sign, remember. And number 3, when it's of the form k f prime f raised to any n, the general answer when we integrate is just f of x all raised to n plus 1, then you adjust for a constant. So that's the summary of the whole video. So just to apply all the knowledge we've learned, let's do 2 questions from actual P3 papers where it's just application of all that I've taught you. If you listen well to all that I've taught you, that's basically everything you need to know for P3 calculus, differentiation and integration included. So in P3 2024 June, there was this question just for 2 marks. It's so simple that it's just for 2 marks. Sine squared of 3x dx. Find this integral, indefinite, because there's no limits. So you might think, why is this 2 marks? It's so hard. But it's simply because of the reverse chain methods and the simple identities I've told you, that it's so simple, you should just spot it immediately that it's 2 marks. So remember, firstly, this simplifies to half minus half cosine 6x, because 3x it becomes 6x. Yeah, this should be now pretty easy to understand. Sine square 3x becomes this, and then to integrate this is just half x. The integral of cosine is just sine, so sine of 6x minus 1 over 12. If I'm not wrong, this is it. This is why it's just 2 marks. It's 2 lines of working plus c, of course. So first you convert this into this, and yeah, that's the answer. This was actually in the June 2025 paper. That's why it's 2 marks. And then the second question, also worth 2 marks, was integral of x squared plus 4 3 over 2 dx. Now, what format or what general form do you think this matches? It's that form of k f prime fx all raised to a certain power n, because the derivative of the inside function 2x, there is no 2 but the x is there, x raised to power 1, so the derivative is showing up here, hence this matches this format. So the answer will most likely be something like this. Add 1 to the power, so 3 over 2, it becomes 5 over 2 plus c. Then we have to adjust for the constant by differentiating this and checking. So when we differentiate this, we get 5 over 2 x squared plus 4 3 over 2 times 2x. So we get 5x, or the whole thing will be 5x x squared plus 4 raised to 3 over 2. When we differentiate this, we are getting 5x, but we want 1x, so we divide by 5, and that's the answer. That's the answer of the integral, also worth 2 marks. That was just noting that it matches that general form. So this is just, yeah, that's it. That's a key application of what I told you. Yes, thank you for watching. That's the whole of P3 calculus, those 2 differentiation videos and this 1 integration video. That should prepare you for anything you need to know about P3 calculus in general.